Good morning. Greetings from the Institute of Global Professionals IGP Bangladesh. Thank you all for joining us and staying with us till the end. Honorable knowledge seekers, today I am your host for the morning. My name is Jannatun Naima. I am from Bangladesh. Dear knowledge seekers, I am proud to be associated with IGP as a global member. IGP, a non-profit organization, is a social and ISO certified international training institute in 3 years. We already served 3 million knowledge seekers from 100 countries. IGP is internationally recognized and globally accredited. We are connected to more than 250 professions and 4,500 organizations. Institute of Global Professionals IGP and ISO 9001 2015 and 10002 2018 is a training facility for skill development which was founded in 2020 and is generating competent candidates to meet demand in the global labor market by providing professional qualifications. The Institute of Global Professionals is an educational institute that provides social work globally recognized and reputable. We serve students and community research providing holistic social work and education. We believe that it's not effective to increase one's skill just by acquiring formal education. So, we provide effective training and consultation to generate proficient generation all over the world. We distribute our service locally, nationally, and internationally to students, job seekers, job holders, and also for learners through respective campus location and distance learning platforms. We are an occupational and dependable institution. IGP is one of the famous online institutes from all over the world. Our vision is education isn't a business product, it's a part of our human rights. Based on our vision, we are trying to reach all corners of the world for free webinars, seminars, courses, awards, quiz competition, mentoring, and counseling, etc. On the other side, we also trying to serve more than 100 premium service for free like create on portfolio website, resume builder, cover letter, motivation letter, and world knowledge platform for gathering general knowledge which can upgrade audit. Kids learning game website, free courses, converter sites, and many more. We help to empower youth to learn to meet their expectations and dreams and become highly skilled people. We implement several trainings programs, webinar, and offline online courses for youth and learners by professional trainers, speakers, and coaches. Our sessions are conducted by globally renowned professionals to develop all kind of to youth and to promote the education of their abilities and responsibilities. To ensure excellent and in-depth instruction, we arranged with qualified trainers, speakers, and instructors. We extend free services to more than 3 million knowledge seekers in the last 3 years. We have affiliation with universities and organizations in 70 different countries. Virtual mouse singings with many colleges and organizations have been accomplished. We are working to create a legendary generation of future scholars and citizens who will be accountable. We are constantly prepared to assist all knowledge seekers with valuable service. Spreading knowledge is crucial for the Institute of Global Professionals. We believe that knowledge is love and light and vision. So we try to understand the need of today's generation and will serve them with good research and practiced method. We have masked a genuine concern for the learners we represent. More diversity, growth, and innovation are required to lead a lesson with professionalism, passion, and integrity. IGP members are committed to offering effective, best quality service and continual improvement so that individuals who seek information can improve their skills and value. Before we move to the next, let me remind don't forget to share, tag, and mention your friend in the comment box. Your support is very valuable to us. Before we move to the next, let me remind don't forget to share, tag, and mention your friend in the comment box. Your support is very valuable to us. Moving to the next, with your continuous support, we already completed 1,143 webinars successfully. At present, we are going to start our 1144 program. Name is Power Quality Issues and Solution. And today our speaker is Sir Dr. Nirav Karela. from India. Before I hand over the stage to Sir, I want to share a very little bit about our speaker. He is Assistant Professor, Department of Electrical Engineering, School of Technology, PDEU, from Gandhinagar. Now, very important moment for me to invite our speaker to IGP with his presentation. Hello, sir.
Good morning, ma'am.
Good morning, sir. How are you?
I'm fine. How are you?
I'm also fine, sir. Sir, from IGP Knowledge Seekers, want to hear from about you.
Okay. So, good morning and a warm welcome from India and Gandhinagar, Gujarat. Myself, Dr. Nirav Karelia. By qualification, I am PhD in electrical engineering, and my research topic is power quality, and particularly, I have worked on UPQC. And I'm going to introduce this device in the last, in very brief. So, my research work is related to multi-converter UPQC and its use in renewable energy sources which are integrated to the grid. So let me introduce myself in a very brief that I have almost 27 years of industry and academia experience, and presently I am working as a assistant professor in Department of Electrical Engineering at Pandit Deen Dayal Energy University situated in Gandhinagar, Gujarat, and that is from India. Uh, can I start, ma'am, my presentation? So yeah,
Yes, sir. Yes, sir.
okay, thank you, ma'am. So let us start with my session, which is on a introduction to power quality. So in very brief, I will introduce what is power quality and then the issues related to that and solution of the same. So this will be my presentation outline where I will briefly introduce power quality. Then we'll look into the concerns of power quality and parameters to gauge the power quality. The major concern of power quality, which is harmonics, which are multiplier frequencies of the fundamental. So sources of harmonics and then troubles due to harmonic pollution. Then its solution is classified as a harmonic filters, and the previous part, or means the first part will be the passive filters and later one will be active power filters. So without wasting time, let us start. So introduction to power quality. So, as a layman, one should ask that what is power quality? So, because power is a product and we are purchasing it, so a product should have a quality criteria. So, let me define power quality. It is a simple term, yet it is describing a multitude of issues that are found in any electrical power system and is subjective term. The concept of good and bad power depends on the end user. If a piece of equipment functions satisfactorily, the user feels that the power is good. If the equipment does not function as intended or fails permanently or prematurely, there is a feeling that the power is bad. In between these limits, several grades or layer of power quality may exist depending on perspective of the user. So, what is power quality? It can be defined in many ways though. A stable voltage and undistorted waveform are two characteristics which define power quality the most. Power, in short, is a product of voltage, current, and a phase angle between the same, which can be measured in time also and in angle also. Now, load currents are governed by the load, so we cannot control the current and waveform of the current. Again, time cannot be changed because it again depends on the type of load. Only voltage is controllable. So, in short, many of the researchers take power quality as a voltage quality. Now, let us come to power quality concerns. So, basically, there are seven types of power quality concerns. First is power frequency disturbance. The second is electromagnetic interference, power system transients, electrostatic discharge, power system harmonics, power factor, and grounding and bonding. Now let us look in a little detail of all this concern one by one. So, power frequency disturbance. What is it? So, power frequency means, let me clarify. Power frequency is a frequency at which we receive our electrical power at our socket, at our household or maybe industry. So, in particularly our area, or that is South Asia Pacific region, most of the countries do have a single phase power at 230 volt single phase at 50 hertz. So 50 hertz is a power frequency. So any disturbance taking place at this voltage and this frequency, not voltage but the frequency, are known as power frequency disturbance. So in a way, power frequency disturbances are low frequency phenomena that result in voltage sag and swell. I'll define sag and swell later in the slides. This may be source or load generated due to faults or switching operations in the power system. There can be many reasons of sag and swells. The end result are the same as far as the susceptibility of electrical equipment is concerned. The next is electromagnetic interference. In short, it is known as EMI also, electromagnetic interference. It refers to interaction between electric and magnetic fields and sensitive electronic circuits and devices. EMI is predominantly a high frequency phenomenon. Many a times we might have observed, particularly when we watch TV with the help of aerial reception, not the cable one. At that time, if any of the IC engine, that is a bike, is passing by, due to the sparking in spark plug, it used to create a electromagnetic interference, and that was induced in our aerial reception of TV channels. At that time, we could see some particular noise lines on the picture, and again along with the hissing sound. So that is a practical example of electromagnetic interference a layman can experience. The mechanism of coupling EMI to sensitive device is different from that for the power frequency disturbances and electrical transient. So as in the beginning I told that electromagnetic interference is having a high frequency. So it is altogether different from power frequency disturbance. The mitigation of the effects of EMI requires special techniques, as we'll see later. Radio frequency interference, again, it is far more higher frequency than the EMI also. It is the interaction between conducted or radiated radio frequency fields and sensitive data and communication equipment. It is convenient to include RFI in the category of EMI, but the two phenomena are distinct. Power system transient. So power system transients are fast, short duration event that produce distortions such as notching, ringing, and impulse. So in a way, transient can be defined as a sub-cycle events. Sub-cycle means our cycle frequency that is 50 cycles. So each cycle contains 20 milliseconds. So any of the disturbance having a repetition of less than 10 millisecond, that is half of the cycle, or 20 milliseconds can be known as a power system transient. The mechanism by which transient energy is propagated in power lines, transferred to other electrical circuits, and eventually dissipated are different from the factors that are affecting power frequency disturbance. Next is electrostatic discharge, that is, in short, it is known as ESD, is a very familiar and unpleasant occurrence. In our day to day life, ESD is an uncomfortable nuisance we are subjected to when weather is dry and cold due to interaction of plastics, synthetics, or man-made fiber. And this is particularly the winter in our region is a season where there is means very less amount of moisture available. Due to that, whenever man-made plastic fibers or synthetic materials are rubbed together, we may feel electrostatic discharge in terms of a little spark, and many a time it is unpleasant one. So that is the biggest example of ESD. But at high levels, ESD is harmful to electronic equipment, causing malfunction and damage. So yeah, whenever we are dealing with very sensitive and delicate circuitries, such electrostatic discharge voltages are so harmful that they may permanently or maybe temporarily hamper the operation of these circuits and damage it permanently. The next is power system harmonics. So let me talk something about harmonics. Harmonics are the multiplier frequencies of the fundamental frequency. So as I already have told that in India or in our region, our power frequency is 50 hertz. So any integer multiple of this frequency like 100 hertz, 150 hertz, 200, 250, 300, 350, these are all harmonic frequencies. And when the multiplier is odd one like 1, 3, 5, 7, 9 up to n minus 1, it is odd frequency. And when the multiplier is even number 2, 4, 6, 8, it is a even harmonic. So voltage and current harmonics have undesirable effects on power system operation and power system components. In some instances, interaction between the harmonics and the power system parameters, there are R and resistance, inductance, and capacitance, can cause harmonics to multiply with severe consequences, which is known as a resonance. Next is power factor. Power factor is a cosine of angle between voltage vector and current vector, or in a way, we can take it as a lagging or leading of current with respect to voltage waveform. In some cases, low power factor is responsible for equipment damage due to component overload. The next concern is grounding and bonding. So, grounding and bonding is one of the more critical issues in power quality studies. Grounding is done for three reasons. The fundamental objective of grounding is safety, and nothing that is done in an electrical system should compromise the safety of people, that is personnel working on the working in the environment. The second objective of grounding and bonding is to provide a low impedance path for the flow of fault current in case of a ground fault, so that the protective device could isolate the faulted circuit from the power source. And the third use of grounding is to create a ground reference plane for sensitive equipments. This is known as SRG, Signal Reference Ground. Now let us talk about power quality parameters. As I told previously, that to measure quality of power, we have to have some parameters. So these are the parameters. The first one is blackout or interruption. So here we can see that this is a routine power wave or a voltage wave, and it has been interrupted for certain time, and once again it has started. So this event or this parameter is known as blackouts. Brownout means here we can see that the amplitude of the waveform, that is voltage, is normal one, and for this much of time the voltages are getting reduced, that is RMS reduction, and that is sustained one. So this phenomena or parameter is known as brownout or undervoltage. Now sag or dip, again it is a RMS reduction, but this is for some very stipulated time, some couple of cycles to maybe couple of seconds only, but it is not sustaining, so it cannot be called undervoltage. The same way harmonics, due to the introduction of higher frequency, the wave shape of routine or the ideal waveform of voltage is distorted, as can be seen from this figure. So harmonic is one of the major concern in power quality. Noise, here we can say that very high frequency signal is imposed on our power frequency, and that's how it is creating noise. The next one is notching. Notching is a clipping of a voltage waveform, and it can be defined as a opposite polarity. So here we can see that a waveform is proceeding in a positive half, whereas notch is in a negative direction or a opposite of that. Swell, again it is a reciprocating or inverse of sag, which is a RMS increment for some moments. Transient, as we know that it is very high frequency with respect to power frequency. It is evident for couple of microsecond to milliseconds. Here we can say frequency variation, it is also a power quality parameter. And short circuit, worst electrical accident or phenomena in power system. So these are all the parameters with the help of which we can measure the quality of power. Now, what were the conventional remedies to harmonic pollution? So voltage regulators, power conditioners, uninterrupted power supplies, surge suppressors, they were all the conventional devices which were dealing with, or means which were used to mitigate the power quality issues, but there are lot of limitation through the use of this equipment. We'll discuss later in detail. So these were the traditional remedies to power quality improvement. Now let us talk about source of harmonics. So from where do harmonics generate? So any non-linearity in the transfer function of the equipment or the system will create a harmonic. So here we can see that due to this hysteresis band, this voltage waveform has been deteriorated. So we can say that any of the deterioration can be related with the introduction of higher frequency to the fundamental one. Apart from this, power electronics based equipment like uninterrupted power supply, personal computers where SMPS, switch mode power supplies are used, welding machine, printers, mobile, laptop chargers, rectifiers, inverter, variable frequency drive or variable speed drive, both are same, and due to discontinuous current flows. These are all the source of harmonics. Now, harmonic distortion can be in voltage also and in current also. So let us talk about the source from where they are generated. So when voltage source type harmonics they are generated, or means harmonics in voltage are introduced due to diode rectifiers with capacitive filtering, and this circuit you must be well aware of, where this capacitor works as a filter, but at the same time it is just drawing the pulsating current, and due to that there is a voltage distortion or voltage harmonics introduced into the supply. At the same time in current, we can see that when there is a series reactor connected with the load, or load is highly inductive, in that case the current harmonics are introduced into the system. Now, what are the troubles due to this harmonic pollution? So, harmonic pollution may result in wide variety of problems. Just to enumerate, first is parallel and series resonance. Next is increase in RMS and peak values, excessive neutral currents, low low operating efficiencies, overheating of electrical equipment. Now, why overheating? Because when the electrical equipment is designed, it is designed at constant frequency, and due to harmonics, iron losses are incremented than the designed one. Due to that, whatever the cooling system has been designed is insufficient to maintain the rated operating temperature. So due to harmonics, iron losses are incremented, and due to iron losses, the temperature incremented or increased more than the designed one, and which persists over continuous overheating of the electrical equipment. Premature aging of the electrical installation. Now, how premature aging? So, life expectancy of any of the electrical equipment can be considered as a life expectancy of the insulation provided in that electrical equipment. And insulation materials are very sensitive towards heat. And as I already mentioned previously, that due to ion losses and harmonics, there is continuous overheating of the equipment, and due to that, the life expectancy of insulating material reduces drastically, which will result in a premature failure of the installation. False stripping of circuit breakers. Yes, due to harmonics, a sensing device may sense a wrong data or a wrong parameters, and due to that, circuit breaker will trip. Faulty measurements, false fuse blown. Then comes capacitor damage. Yes, here also I'd like to explain how capacitor fails. So we know that capacitor is a device having two conducting plates separated by dielectric. And what is dielectric? Dielectric is insulation material. And as we already know now, that insulating material is very sensitive towards temperature. So any temperature beyond the designed one will drastically reduce the life expectancy of the insulating material, and hence the capacitor may get damaged or may fail before its life ends. Again, kilowatt hour is a unit of energy measurement, electrical energy measurement. And we know that due to distortion of sine wave, maybe in voltage or in current or in both, when this energy is being measured with electronic equipment or digitally, in short, zero crossing is not decided, and there are multiple zero crossing. Due to that, there may be a calculation fault. So it is known as a kWh fault. kWh is unit of power, 1 kilowatt hour. Loss of motor winding and iron loss, perturbing torques on the motor shaft. Now we know that perturbing torques means thrusting torque. It is not a smooth torque prevailing on the motor shaft. How does it happen? When higher frequencies prevail in the supply, due to that, that will create a variable torque which is thrusting in nature. There are positive sequence and there are negative sequence. So negative sequence will exert a reverse direction torque which will create a thrust. So these thrusting torques are known as perturbing torques on the motor shaft. Damage of sensitive electronic equipment that we already have seen. Malfunctioning of phased lock loop circuit, that also we considered, that whenever there are multiple zero crossing, the fundamental zero crossing is missed, or a electronic circuit is confused that which one is the original fundamental zero crossing for measurement. So PLL circuit will definitely malfunction. Again, if the frequency of this interference is very high, then it will be induced into the adjacent communication links, which is carrying very sensitive and important data for control or measurement, and that causes a big problem. Now next is classification of harmonic filters. So as we have seen that the biggest villain in our power system is harmonic. So to mitigate harmonics, there are two approaches. One is the conventional one, which is passive filters, and other is latest state of the art advanced technology, advanced or active power filters. Passive filter, as the name suggests, uses resistance, inductance, and capacitor in particular fashion. So there are three topologies: series filters, shunt filters, and damped high pass filters. Now, in active power filters, they use power electronic switches and processors, that is computation. So there are basically three classification. The first one is on the base of converter. Which converter are we using in active power filter? So there are two converters, as we already have seen in the previous slides, that is current source inverter and voltage source inverter. Now next is supply system base. In supply system, we can have a single phase, that is two wire, phase and neutral, three wire, that is three phase three wire, that is balanced load, and three phase four wire, that is distribution system. And again, there are so many, or there may be many single phase loads also. So three phases and one neutral. Now topology based, there is a series active filter, there is a shunt active filter, then comes unified power quality conditioner, which is a combination of these two, series and shunt approach, and hybrid APF. Hybrid active power filters consist of either of these three and the passive filters together. So that is a hybrid active power filter. Now, how are passive filters used in the power system? So as we know, here in the figure, it is seen that the first one is first order. This is undamped high pass filter. This is second order filter, which is again high pass filter. Then comes second order damped high pass filter. This is a fourth order double band pass filter. And this is a composite filter, which is a combination of the previous ones. So these two branches, there can be more number of these branches. Here we can see that. Okay, sorry. Yeah, here we can see that in a composite filter, it consists of two or more branches of bandpass filters tuned at low order harmonic frequencies and a parallel branch of high pass filter tuned at higher frequencies. Just a minute. Now, in the next slide, this figure shows a three wire series configuration. We can see here that each such series filters are designed for some particular harmonics, like this C5 means fifth harmonic, this is for seventh harmonic, and this is a three phase three wire, that is a balanced system where which is catering three phase three wire non-linear loads, but the configuration is series one. Here in shunt, we can see that all these filters are connected in parallel. Similarly, for three phase four wire system, here we can see that these three are phases and the bottommost is a neutral wire, and similarly in a passive filter. Now here comes a series active filter. We can see that here there is a converter connected. There is a single phase transformer, or it can be used as a or three phase transformer also. This is going to compensate voltage sag, voltage swell, and source voltage harmonic mitigation. We can see that there is a local energy bank which can be a capacitor in most of the times, and this inverter will draw energy from here, create a compensating voltage, and it will add in mutual coupling in the main lines, and the load is scattered without any power quality issues. In shunt active filter, here we can say that it will take care of load current harmonics and reactive power compensation. Again, the topology will remain the same. The converter is the same one. It will draw energy from the local capacitor, and it will directly connect, that is bonding, to a point of common coupling, and it will mitigate load current harmonics and reactive power compensation. Now, looking towards this shunt and series active power filters, series active power filter will take care of all the voltage related issues, whereas shunt active power filter taking care of load current related power quality issues. But what if we want both voltage and current related issues? In that case, there is a combination of series and shunt active power filter. So we here very well can see that this is a shunt active power filter. This part is series active power filter, and they are connected through a common DC link capacitor. And now it will give a comprehensive solution towards any power quality related issues of voltage, source voltage, as well as load current. So, with this, I would conclude my speech. The session is open for question and answer.
Thank you so much, sir, for your rich content presentation, which can impact our knowledge seekers surely. After your presentation, I hope our knowledge seekers can learn something new, which was our only intention. Learn and grow together, IGP knowledge seekers. Once again, thank you so much, sir, for your presentation. Now it's time for our question answer session, which is the one more valuable part of our regular webinars. Honorable sir, please stay with us after a short video. We will be back in our session part 2, which is question answer part.
Sure, ma'am.
Dear IGP knowledge seekers, please ask your question in the comment box as much as you want to know from our speaker. Thank you. After question answer, we have webinar certification and online quiz competition. Welcome back, sir.
Yes, ma'am.
Uh, our first question from Aaron. Blessed Sunday, everyone. Good day, Dr. Nirav Kerala. What are the main cause and effects of harmonics? What are the basic solutions to mitigate harmonics? Thank you.
Okay. Thank you, Aaron, for the question. So, main causes of harmonics are non-linearity in the system. So, anywhere in the any transfer function of equipment or system is there, it will cause harmonics. The reason behind or the proof of harmonics is lies in Fourier series analysis. So we know that any of the distortion of waveform happens, or if it is repetitive, then it can be analyzed with the help of higher frequencies, and that is done with the help of Fourier analysis. So whenever there is any non-linearity involved in the system, let us say in transformer magnetization, so that magnetization characteristic itself is a non-linear one. For our useful utilization, we use linear range only. But during the charge up of transformer, when it is charged, at that time we traverse through the non-linear part also, and that will distort the waveform. It means it is the introduction of harmonics. Apart from this, there are many instances where, let us say, there is a continuous switching taking place. In particularly power electronic switching, we use very high frequency switching. So whenever such switching is taking place, there is a lot of amount of non-linearity is introduced. It means it is going to introduce harmonics. The effects of harmonics I already had enumerated. There are lot many effects of harmonics, but the major one is higher harmonics. That is, higher frequency causes more ion losses in the equipment. Due to that, the temperature is incremented more than the designed one or the rated temperature rise. Due to that, insulation will die down early. The life expectancy of insulation will reduce drastically, and hence the equipment will fail earlier than it should. And what are the basic solution to mitigate harmonics? So as I mentioned, there are two approaches. One is passive filters. They do have their pros and cons both. Due to the limitation of time, I couldn't include all those topics. But passive filters are very cheap and sturdy, but at the same time they offer fixed solution or fixed response. It is a static one, so it cannot comply with the changing situations. And the other approach is active power filters. No doubt they are very adapting and best, we can say, but at the same time, because it is using costly power electronic switches and processors and complex circuitry, they are very costly. So these are two basic solutions to mitigate harmony. I hope I have justified the question.
Thank you, sir. Question from Jordan. Good day, sir. How do you identify power quality issues? Thank you, sir.
Okay, so yeah, because as I already have told, power is a product and we have to purchase it. And if it is a product, it has to be purchased. Then there has to be parameters to quantify the quality. So there are parameters like sag, swell, then comes harmonics, noise. So these are the parameters. Flicker. With the help of this parameter, we can quantify the power quality.
Thank you, sir. Please, dear IGP knowledge seekers, ask your question in the comment box. We are waiting for your question. Dear IGP knowledge seekers, please ask your question in the comment box. We are waiting for your question. Our speaker also waiting for your question. Okay, sir. Thank you so much, sir. We have done all the question answer. Once again, thank you so much, sir, for your time in IGP. We have learned a lot from you with the new topics. It will add some value to day activity along with our academic and professional growth. Honorable sir, hope to see you again with a new topic and a new day. Thank you, sir.
Thank you very much. At this moment, I would also take the opportunity to thank and congratulate Institute of Global Professionals for such a noble work you are doing. And I really congratulate you and your team. Thank you very much to you and all the knowledge seekers. Thank you. Hope to see you soon again with new topics.
Okay, sir. IGP Knowledge Seekers, it's time for the webinar certification process, the most attractive and powerful part of our regular webinar. After a short video, we will start our webinar certification. After webinar certification, we have an online quiz competition and quiz certification. Dear IGP Knowledge Seekers, today's program name is Power Quality Issues and Solutions, and the code is IGP 1221. Without code, no one is eligible for certificates. With code, you can claim your certificates anytime. Today's program name Power Quality Issues and Solution, and the code is IGP 1221. Without code, no one is eligible for certificates. With code, you can claim your certificates anytime. How to claim a certificate? You have to go www.eduigp.com. Then click sign in, then log in if you already have an account, or create a new account if you are new. Once logged in, click free webinars. Select the webinar title and click continue. Get enrolled if you haven't enrolled yet. Type the code in your certificate code box. Click Get Your Certificate. It is auto downloadable in your PDF file already. Just check in your file manager or download folder. Don't forget to leave a review in our Facebook page, website, and in Google. Dear IGP Knowledge Seekers, it's time for the most engaging part of this webinar, which is an online quiz competition, which is our regular webinar activity. After a short video, we will be back and start our online quiz competition. Dear IDP knowledge seekers, time for the online quiz competition. To join the online quiz competition properly, please follow my instruction carefully. You have to go www.slido.com and find today's quiz or scan this QR code for direct joining. And the code is morning. Please join in slide with code and the code is morning. You can see 26 people already joined. After 3 minutes, we will start our quiz competition. কাজ করতেছে যে। After 2 minutes, we will start our online quiz competition. For the quiz session, you have to go www.slido.com and the code is morning. After 1 minute, we will start. Uh, Join quickly. So we are going to start the quiz. Our first question is few issues have to be considered in the development and implementation of digital solution in healthcare. Is it true or false? And the correct answer is false. 20% people are correct. In the leaderboard, Joel is holding first position, second Imli, third Jinilin, fourth Jay, fifth Jinnat. Second question, decisions typically involve what type of issues that lead to conflicting solutions? Ethical, political, or market economic? And the correct answer is ethical, political. 50% people are correct. In the leaderboard, we have in the first position Imdi, second Joel, third Udit, fourth AMB, fifth Charlie. The third question is process of investigation and organization process with the aim of identifying any potential issues and to provide solutions. Option 1 audit, option 2 credit report. And the correct answer is audit. 83% people are correct in the leaderboard. First is Imli, second Joel, third Udit, fourth Joseph, fifth Charlie. The fourth question is describes a quality or behavior of a person, infringement or characteristics. And the correct answer is characteristics. 93% people are correct in the leaderboard. First position is Simbi, second Joel. The next question, nuclear power has regained some popularity as an energy resource because of low CO2 emission or new solution for waste disposal. And the correct answer is low carbon dioxide emission. 55% people are correct. In the leaderboard, first position is Emily, second Joel, third Udi. The sixth question is moral principles applied to business issues and actions. What is correct? Code of ethics or business ethics? And the correct answer is business ethics. 61% people is correct. In the leaderboard, first position is holding MD, second Joel, third Udit, fourth Joseph, fifth Charlie. The seventh question is how can you keep the family focused on the issues during an interview? Option 1, tell them to state the facts. Option 2, redirect the conversation. And the correct answer is redirect the conversation. 13% people are correct in the leaderboard. First position is holding Emily. Second is Udit. Third is Joel. Fourth Jay. Fifth Charlie. The eighth question, how to explain the role and quality control in manufacturing. Controls the quality, sigma stand for manufacturing or controls the quality, B sigma stand for manufacturing. Which one is correct? And the correct answer is controls the quality, B sigma stands for manufacturing. 28% people are correct. In the leaderboard, first position is Imre, second Udit, third J, fourth Joel, fifth MB. How the ninth question is how can you keep the family focused on the issues during an interview? Redirect the conversation or ask yes or no question. The question answer is redirect the conversation. 93% people are correct. In the leaderboard, first position is holding Emily, second Udit, third Jay, fourth Joel, fifth Jannatul Firdaus. The last question is the practice of seeing and ex- expressing problems as opportunities to create solutions. Option 1 risk, option 2 opportunity recognition. And the correct answer is opportunity recognition. 76% people are correct. Congratulations, Imli, for holding first position, second third Jewel, fourth Udit, fifth Janatul Firdaus. Congratulations to our webinar online quiz competition winners top 10. Congratulations again. Slido will take a few minutes for finalizing the result. And after that, we will issue our online quiz competition certificates on our official Facebook page and group. The group name is Institute of Global Professionals. At the end of our session, we can say properly feed your skills. Never stop learning, cause life never stop teaching us. Be happy and stay safe. See you again and again. We want your participation in every program. If you want to live a happy life, tie it to goal, not to people or things. Albert Einstein. Before I say or hit the end life button, once again, thank you all IGP knowledge seekers for your active participation as always. See you in the next session. Thank you.